this lesson involves finding the area of different kinds of quadrilaterals. So let me just make a note of that. That's our goal. Now, you folks know from our previous studies that there are different kinds of quadrilaterals. Right now, we're going to focus on squares, and rectangles, and parallelograms. The formula that we'll use for actually all three of these is very simply going to be that the area is equal to the base times the height. So this is our general formula. Before we start into this, though, I want to remind you that there are some skills that you learned previously. They're going to come to play here. First of all, when you're finding area, the units that you're working with are very important to pay attention to. You need to know what units you are given and what units you are asked to find your answer in. Sometimes the units will involve inches, sometimes feet, sometimes yards. So if you have, let's say, 24 inches, you may have reason to convert that to feet. Remember that you're going to divide by 12 to get your answer in feet. Let's suppose you have 5 feet and you have reason to convert this to inches. So you would multiply by 12. And that would give you 60 inches. Notice that when you're going from a smaller unit, inches, to a bigger unit, feet, you're going to divide. While when you're going from a larger unit, feet, to a smaller unit, inches, you're going to multiply. And that will always be the case. Bigger to smaller, just simply multiply. If you have 10 yards and you have reason to convert that to feet, you're going to multiply by 3 to get 30 feet. Bigger to smaller, multiply. Let's suppose you have 15 feet and you have reason to convert to yards. Well, since you're going from feet to yards, that's smaller to bigger, so you would divide by 3 to get 5 yards. So the only other conversion that we need to do right now is going from yards to inches and inches to yards. and the number that you're going to be using to do that, your multiplier or the number you divide by, is going to be 36, because there's 36 inches in every yard. So if you have, let's say, 108 inches, and you have reason to convert that to yards, you're going from smaller to a bigger unit, so you're going to divide, and the number you divide by is 36. 108 inches is the same as 3 yards. But let's suppose you have 20 yards, and you want to convert that to inches. You need to multiply, because you'll be going from bigger to smaller, and you multiply by 36. That would be 720 inches. So this represents just a review of how to change back and forth between inches and feet, feet and yards, inches and yards. Like I said, a previous skill. This will be part of a lot of your problems. But you won't know to do this unless you're paying attention to the units you're given and the unit you're asked to find your answer in. Area is always expressed in square units. What that means is your answer will either be inches squared, or feet squared, or yards squared. Keep this in mind. To get inches squared, you have to multiply inches times inches. To get feet squared, you have to multiply feet times feet. To get yards squared, you have to multiply yards times yards. So, let's suppose the problem asks you to find your answer in square feet, but the units you're given are in inches. So what you would do is you'd take the time at the outset to convert the given dimensions into the units you're asked to find your answer in. So if you're trying to find an answer in square feet, but the given dimensions are in inches, you'd change inches to feet, and then you would multiply to get your area. This, again, is going to be the formula that you use to find the area of squares and rectangles and parallelograms. Let's do some problems involving finding the area of a square. Here's our formula. Area equals base times height. But don't forget, a square is unique. A square is unique because all 4 sides have the same length. So if I would call the side S, then I would automatically know that each side has the same length, S. So when I go to find the area, base times height becomes S times S, which you know is just simply S squared. So this formula is really the same as this formula, but we'll use this for a square. Some examples. Let's suppose you know that this is a square that's given, and that you're told that the side of the square has a length of, let's say, 12 inches. So take note right away. Inches. And you're asked to find the area. Area equals. And you're supposed to put your answer right there. But wait, right after the blank, it says inches squared. You now know that when you put the answer here, it has to represent the number of square inches. But it's very possible that you could be asked to find the area in square feet. Or you could be asked to find the area in square yards. To get square inches, you'd multiply inches times inches. So that would be 144, 12 times 12. To get the area in square feet, however, you'd have to do a little conversion. 12 inches is the same as 1 foot. So now you're going to multiply 1 times 1 to get 1 square foot. To get the area in square yards, we need to multiply yards times yards. Remember, if you're converting from feet to yards, you're going from smaller to bigger. So you're going to divide. 1 foot is the same as 1 divided by 3 yards, or 1/3 of a yard. 1/3 times 1/3 would be 1/9. So it'd be 1/9 of a square yard. All of these values are equal. 144 square inches is the same as 1 square foot is the same as 1/9 square yard. But again, make sure you answer the question being asked, which means be certain that you know what units your answer's supposed to be in. Let's do another example. I'm going to draw another square. And I'm going to tell you that this square has a side length of 6 feet. And we're going to find the area. And we're going to do the same thing we did in the last problem. We're going to find the area in square inches. We're going to find the area in square feet. And we're going to find the area in square yards. This one we'll do first because we already have our units in feet. 6 feet times 6 feet would give us 36 square feet. To get our area in inches, we'd have to convert this to inches. 6 feet times 12 inches in every foot would be 72 inches. So to find this answer here, I need to multiply 72 times 72, or 72 squared. That's probably a calculator problem. And that turns out to be 5,184 square inches. Yards is not so bad. I'm probably predicting here that I can do that without a calculator because 6 feet is the same as 2 yards. How did I get that? 6 feet divided by 3 feet gives me 2 yards. And without a calculator, to get the area in square yards, I'd multiply 2 yards times 2 yards to get 4 square yards. I mentioned earlier that there's going to be some other previously learned skills that come to play. And let me run through a couple of those right now. You are going to need to be able to work with a 45, 45, 90 triangle, and also a 30, 60 90 triangle. By way of review, remember that in a 45, 45, 90 triangle, the legs are the same. It's actually an isosceles right triangle. And then the relationship between the leg and the hypotenuse is this. Whatever the leg is, multiplied by the square root of 2 will give you the length of that hypotenuse. The other special right triangle is your 30, 60, 90. Recall that in a 30, 60, 90, you have a short leg that's across from the 30, you have a long leg that's across from the 60, and then of course the hypotenuse is across from the 90. Whatever this short leg is here, if you want to find the hypotenuse, you just double the short leg. So the short leg times 2 will always give you the hypotenuse. And whatever the short leg is, if you multiply it by the square root of 3, you'll get the long leg. So that's just a quick review of the relationship between the sides of a 30, 60, 90 and a 45, 45, 90. That's going to come to play for you. Look at this situation. Here's a square. So I'm telling you, this is a square, which means you automatically know all the sides are the same. And I'm going to draw in a diagonal. Now, before I put any numbers on the figure, let's think about what just happened. When you draw in that diagonal, you know what just happened? You formed 2 of these guys right here. Yep, you got a right angle, right angle. These are 45s. So you have 2 45, 45, 90 triangles. And if I give you, let's say, the length of this diagonal, what I would be giving you is the length of the hypotenuse of a 45, 45, 90 triangle. So let's suppose I tell you that the hypotenuse here is 10 inches. And then I ask you, what's the area of this square in square inches? Well, this would be my side here. And if I had that value, I would just square it. S times S would give me my answer. So the first order of business is to figure out what S is. Let's look back up here. If the leg times the square root of 2 will give you the hypotenuse, but you already know the hypotenuse, then you divide by the square root of 2. So each side here is going to be whatever the hypotenuse is, 10, divided by the square root of 2. So I'll just find the area. The area is just very simply one side, 10 divided by the square root of 2, times the other side, 10 divided by the square root of 2. On the top, 10 times 10 is 100. On the bottom, the square root of 2 times the square root of 2 is 2. And then 100 divided by 2 is 50. So it would be 50 square inches. So just to review this problem, you needed to know this in order to find the area for this square. So this skill and this knowledge involved with this special right triangle came to play in trying to answer this question. Let's do another one that's almost like that. This is a square, and here's my diagonal here. And I'm going to tell you up front that the area of this square is, let's say, 18 square inches. So you already know the area. And then I'm going to ask you, what's x? What's the length of the diagonal? Well, here's the deal. We know that the side of the square squared will give you the area, but we already know the area. It's 18. So when you know the side, you square it to get the area. But when you know the area and you're trying to get the side, the operation that you would perform would be finding the square root. So when I take the square root here, I'm going to get s, and here I'm going to get the square root of 18. So s is equal to the square root of 18. But don't forget, this is a 45, 45, 90 triangle. And if I know the leg, all I have to do to get the hypotenuse, which is the same as the diagonal, is multiply by the square root of 2. So x is going to equal the square root of 18 times the square root of 2, which gives me the square root of 36. And you folks know 36 is a perfect square, so the final answer is 6. So x would equal 6. Once again, you need to know this to do this problem involving the area of a square. Let's turn our attention to finding the area of a rectangle. We'll do some problems. Here. Now this would be the base, and this would be the height. Simple formula, same formula, base times height. The only difference here is that for a rectangle, not all four sides are the same. So let's suppose I tell you that this is, let's say, 3 feet. And this is, let's say, 12 inches. So I'm certain you noticed that the units I've given you for the dimensions of this rectangle are different. Feet, inches. So be careful. Make sure you answer the question using the correct units. So I'm going to say to you, what's the area of this rectangle in square feet? The only way you can get square feet is by multiplying feet by feet. This is cool. It's already feet. This is inches. So I would take 12 inches and I would divide by 12 and I would change that to 1 foot. So now when I want to find the area in square feet, it's going to be 3 times 1 would be 3 square feet. However, let's suppose I said, what's the area in square inches? So I'm going to use the 12 because that's inches, but I need to convert this. 3 feet times 12 inches would be 36 inches. So to find the area in square inches, I'd have to multiply 12 inches by 36 inches. It's probably a calculator problem to get 432 square inches. It's also possible that I could ask you to find the area of this rectangle in square yards. The only way to get square yards is to multiply yards times yards. So let's go back up here. 1 foot would be, if I divide by 3, 1/3 yard. 36 inches is 1 yard. So when I got to find the area here, I'm just going to multiply 1 yard by 1/3 yard, which would give me 1/3 square yard. Another problem involving rectangles. The area of a rectangle is the base times the height. This is the height right here. But I don't know the base, but I can figure it out. How am I going to figure out what the base is? Very simply, Pythagorean theorem. This is a Pythagorean theorem problem before it's an area problem, because you can't find the area unless you find the base. So I'm looking at this right triangle, and I'm just going to use this little shortcut calculation. You know, I'm using a squared plus b squared equals c squared. But if I'm going to do this on my calculator, I'm going to do the square root of 13 squared minus 5 squared. And it's going to come out to be 12. So the area then would be base is 12 times the height is 5, would give me 60. And I didn't put any units here, but if I did that, it'd be 60 inches squared. Let's do a couple more rectangle problems. So, I was going to give you this value, but pretend that you don't know that. So here we have a rectangle, and I've drawn in the diagonal, and I've told you that this angle right here is 30 degrees. Well, we know this is 90, and if that's 30, that has to be 60. And the area for a rectangle is base times height. But I don't know either one of those things, not right away anyway. I know that the diagonal is 20, but what you need to see is this diagonal is really just the hypotenuse of a 30, 60, 90 triangle. This side right here, which is my height, would be the short leg of that 30, 60, 90 triangle. What's the relationship? Well, the relationship is that whatever the short leg is, if you multiply by 2, you get the hypotenuse. So if I do a quick division problem here, 20 divided by 2, that's going to give me the short leg. Now that I know the short leg, I can get the long leg. Remember, the long leg's across from the 60. Whatever the short leg is, you multiply by the square root of 3 to get the long leg. So now my area is going to be the base, which is 10 square roots of 3, times the height, which is 10. Now, if you are asked to give your answer as a precise answer in simplified radical form, you would just simply multiply the two whole numbers. That gives you 100, and the radical 3 just goes along for the ride. Or you could go to your calculator and multiply 100 times the square root of 3, and you can end up with the decimal approximation. I'm coming up with 173.21. So this problem, which is a problem that asks you to find the area of a rectangle, requires you to apply previous learned skill. The previous learned skill is the relationship, knowing the relationship between the sides of a 30, 60, 90 triangle. The last figure we're going to look at and find the area for is a parallelogram. The formula is not changing. The formula is the same. The difference is that we no longer have 90-degree angles in the corner, which means that this side is no longer going to be the height. The height is always the perpendicular distance between the two parallel sides. So this is going to be your height. This will still be your base. So if you know the base is, say, 20, and the height is, say, 10, all you got to do is plug those numbers in. You'd have base of 20 times height of 10, and the area would be 200. And I didn't specify the units here, so I'm just going to write units squared. All right. Now, what's going to happen when you're solving problems that ask you to find the area of a parallelogram is this. You're going to have to apply some previous skill to find either the base or the height. So they're going to be multi-step problems. You're not going to have just these two numbers given to you that you can just plug in and multiply together. You wouldn't want it to be that easy anyway. So let's look at this situation. Let's suppose I tell you that you have this parallelogram, and the base of this parallelogram is divided into two parts. And this part here has a length of 5, and this part here has a length of 25. Does everybody agree that the base for this parallelogram would now be 30? Because you'd add those two parts together. And then let's suppose you're told that this side of the parallelogram has a length of 13. Now, once again, that's not the height. This is the height. So, in order to find the area here, you need to know both the base and the height. We're good on the base. It's 30. The height, though, we have to figure out. And once again, we're going to use the Pythagorean theorem. And we're focused on this triangle right here, which is a right triangle. Remember, this height is always perpendicular to this side. So that means that this triangle is always a right triangle. So H then, to use my little calculation shortcut, is going to be the square root of 13 squared minus 5 squared. And it turns out to be 12. So area is base times height. Base is 30. Remember, the 30 I got by adding the 5 and the 25 together, times the height, which is 12, and the area would be 360 square units. Before I do another problem asking you to find the area of a parallelogram, let me remind you of another skill that we previously learned. We learned that if we have a right triangle here, and we know this angle right here. Let's suppose this angle is, I'm just saying that looks like about a 50-degree angle here. And I know that the hypotenuse here has a length of, let's say, 22. And I want to find this value right here, which, just to stay with what we're doing, I'm just going to call H. I could call it any variable, but I'm going to call it H. I have a way to find h. I have a way to find h that involves trigonometry. And in particular, I would use my sine ratio. And I would say that the sine of 50 degrees is equal to the opposite side over the hypotenuse. To solve for h, I would multiply both sides of this equation by 22. So I'd have 22 times the sine of 50 degrees is equal to h. So I'd go to my calculator now. And once I get to my calculator, the first thing I'm going to do is hit my mode button to make sure I'm in degree mode. And I am in degree mode. And I recommend that that's the first thing you do also. So I'm in degree mode. I need to be in degree mode for all these problems. And I'm going to do 22 sine 50 degrees, close that parenthesis, hit enter. And we're going to round to the nearest hundredth on this. And we're going to get 16.85 equals h. Now, let's suppose I take this triangle right here and I make it part of a problem where I'm being asked to find the area of the parallelogram. So look, here's my parallelogram. Here's my 50-degree angle. We'll keep this 22 right here. And let's suppose the base of this thing is, I don't know, I'm just saying 60. All right? And I want to find the area. Well, the area is equal to the base times the height. I'm good with the base. I know it's 60. But I have to find the height. This is the height here. Before I can find the area, I need to find the height. How am I going to find the height? Right here. I'm going to set up a little sine ratio, and I'm going to find the height, just like I did there. I'll do a rerun on that. The sine of 50 degrees has to be opposite over hypotenuse, so that would be h over 22, or 22 times the sine of 50 degrees is equal to h. And when I go to my calculator, I get 16.85 is my value for h. Now I take that value and I plug it in, times 16.85. This is definitely a calculator situation. So 60 times 16.85, and I'm ending up with 1,011 for my answer, for my area, and it would be units squared. So I want to close now, and I'm sure you want me to close now because you're tired of listening, but just a quick review. For all of these problems, we're using the same area formula. Base times height. That's for a square, that's for a rectangle, and that's for a parallelogram. Some preliminary skills, however. You need to remember how to convert back and forth between inches, feet, and yards. Remember, the only way that you can get square yards is to multiply yards times yards. Square feet, feet times feet, square inches, inches times inches. Won't matter if you know that if you do not pay attention to the units you're given and the unit you're asked to find your answer in. We said that for a square, we could take base times height and change it to s squared because the base and the height are the same. When you're trying to find the area of a square then, and you know the side, you're just squaring the side. We said that the 45-45-90 triangle comes to play quite a bit when you're working with squares. In this problem, don't forget, we were given the diagonal, but the diagonal is the hypotenuse. So you divide by radical 2 to get the length of the side. In this situation, we use Pythagorean theorem to find the base. So we have one side, we have the diagonal of the rectangle, we use Pythagorean theorem to find the base, and then we plug into our formula. In this problem, we had to deal with a 30, 60, 90. We're given a diagonal, which is the hypotenuse. We cut it in half to get the short leg. We multiplied by radical 3 to get the long leg, and then we plugged into our formula. We could get the answer as an exact value. That would involve a radical, or we could get the answer as a decimal approximation. Remember, a parallelogram has the same formula as for a rectangle, but the side is no longer the height. Oftentimes you have to find the height before you have all the values you need to find the area. That could involve a Pythagorean theorem situation, like here. We found the height here by using the Pythagorean theorem. Or it can involve any other angle right there, and we'll use a little sine equation, a little sine ratio to find the height. So hopefully my explanations have been clear to you, and you can review this video as often as you want, because the problems that I'm going to assign you to do as your practice are going to be just like the problems I just went through with you. So thank you for your attention, and good luck on your practice sheet.